National Electrical Code, or NEC Table 220.12 provides general lighting loads for various types of buildings. The building types listed include assembly occupancies such as theatres and auditoriums with a range of 0.25 to 2.0 watts per square foot. Educational occupancies like schools and universities range from 1.50 to 3.0 watts per square foot. Healthcare occupancies, which include hospitals and clinics, have a range of 1.50 to 5.0 watts per square foot. Hotels and motels fall between 1.0 and 3.0 watts per square foot. Office buildings range from 0.50 to 1.50 watts per square foot. Restaurants have a range of 1.50 to 3.0 watts per square foot. Retail stores are between 1.0 and 3.0 watts per square foot. Warehouses range from 0.25 to 0.50 watts per square foot. The Osho Guide for the Design of Roadway Lighting from 2015 provides typical lighting power densities for roadways. Interstates range from 1.5 to 2.0 watts per square foot. Urban streets range from 0.75 to 1.25 watts per square foot. Rural roads range from 0.25 to 0.75 watts per square foot. The ESA Lighting Handbook from 2020 provides recommended lighting power densities for various applications. Task lighting, such as in offices and workstations, ranges from 10 to 50 watts per square foot. General area lighting, such as in warehouses and storage areas, ranges from 1 to 10 watts per square foot. Some local building codes may specify minimum lighting power densities for specific occupancy types. These values are general guidelines and may vary depending on factors such as building size, design, and specific lighting requirements. It is always recommended to consult with a qualified electrical engineer or lighting designer for specific project calculations. The NEC Table provides a starting point for estimating general lighting loads, but it is crucial to consider the specific characteristics of the building and its intended use. For example, a hospital will likely have higher lighting requirements than an office building due to the need for specialized lighting in operating rooms, patient rooms, and other critical areas. Similarly, a restaurant with a large kitchen and dining area will have different lighting needs than a small retail store. The Osho Guide offers insights into roadway lighting, considering factors like traffic volume, speed limits, and pedestrian activity. These values help ensure adequate visibility and safety for drivers and pedestrians. The ESA Lighting Handbook provides more detailed recommendations for specific applications, taking into account factors like task illuminance, glare control, and energy efficiency. This handbook is a valuable resource for lighting designers and engineers seeking to optimize lighting systems for various environments. Local building codes may also have specific requirements for lighting power density, reflecting local energy conservation goals and building standards. These codes should be consulted to ensure compliance and to identify any specific requirements that may apply to the project. When determining the appropriate watts per square foot for a building, it is important to consider several factors. Firstly, the type of occupancy, as different building types have different lighting needs. Secondly, the building design, which includes factors like ceiling height, window placement, and interior finishes, all affect the amount of light needed. Thirdly, the specific lighting requirements, which vary depending on the tasks performed in the building and the desired level of illumination. Fourthly, energy efficiency goals, as modern lighting systems are designed to minimize energy consumption while providing adequate illumination. And fifthly, local building codes that should be consulted to ensure compliance with minimum lighting power density requirements. Consulting with a qualified electrical engineer or lighting designer is highly recommended, especially for complex projects or when specific lighting requirements are involved. These professionals can provide valuable expertise in selecting the appropriate lighting systems, calculating lighting loads, and ensuring compliance with all applicable codes and standards. Furthermore, they can help optimize the lighting design for energy efficiency, cost-effectiveness, and occupant comfort. The selection of lighting fixtures also plays a crucial role in determining the overall watts per square foot. Different types of fixtures have varying efficiencies and light output, which can significantly impact the total power consumption. For example, LED fixtures are generally more energy efficient than traditional incandescent or fluorescent fixtures, and they can provide comparable or even better light output. The control of lighting systems is another important aspect to consider. Automated lighting controls, such as occupancy sensors and daylight harvesting systems, can help reduce energy consumption by automatically turning off lights when they are not needed or by adjusting the light output based on the amount of natural light available. These controls can be particularly effective in areas with intermittent occupancy or in buildings with large windows or skylights. In addition to general lighting, task lighting should also be considered. Task lighting provides localized illumination for specific tasks such as reading, writing, or working on a computer. By providing targeted illumination, task lighting can reduce the need for general lighting, resulting in energy savings and improved visual comfort. The NEC provides guidance on calculating branch circuit loads for lighting. Article 220.12 specifies the general lighting loads for various occupancies, which are used to determine the minimum ampacity of branch circuits that supply lighting fixtures. The NEC also provides requirements for the installation of lighting fixtures, including mounting heights, clearances, and wiring methods. These requirements are designed to ensure the safety and reliability of lighting systems. When calculating the total electrical load for a building, it is important to consider not only the lighting load but also the loads for other equipment and systems such as HVAC, appliances, and receptacles. The NEC provides guidance on calculating these loads in Article 220. The total electrical load is used to determine the size of the service entrance conductors, the main overcurrent protective device, and the distribution equipment. Accurate load calculations are essential for ensuring that the electrical system is adequately sized and can safely handle the building's electrical demand. The NEC also addresses the requirements for emergency lighting systems. Emergency lighting is required in many buildings to provide illumination during power outages or other emergencies. The NEC specifies the types of emergency lighting systems that are acceptable, as well as the requirements for their installation, testing, and maintenance. Emergency lighting systems must be designed to provide sufficient illumination for safe egress from the building. In addition to the NEC, other standards and guidelines may also apply to lighting design and installation. For example, the Illuminating Engineering Society, or WISE, publishes recommended practices for lighting various spaces and tasks. These recommended practices provide guidance on selecting appropriate illuminance levels, minimizing glare, and optimizing lighting for visual comfort and energy efficiency. Compliance with these standards and guidelines can help ensure that lighting systems are well designed and provide a safe and comfortable environment for occupants. It is essential to stay up to date on the latest codes, standards, and guidelines related to lighting design and installation. The NEC is updated every 3 years, and other standards and guidelines are also periodically revised. Keeping abreast of these changes ensures that lighting systems are designed and installed in accordance with the latest best practices. In summary, determining the appropriate watts per square foot for different building types requires a careful consideration of several factors, including the type of occupancy, building design, specific lighting requirements, energy efficiency goals, and local building codes. Consulting with a qualified electrical engineer or lighting designer is highly recommended, especially for complex projects or when specific lighting requirements are involved. Adhering to the NEC, IES standards, and other relevant guidelines ensures that lighting systems are safe, efficient, and provide a comfortable environment for occupants. The NEC role is paramount in guiding safe and effective electrical installations, including lighting systems. The Table 220.12 serves as a foundational reference point. However, relying solely on this table may not suffice for complex or specialized projects. Detailed consideration of the actual usage, specific tasks performed within the space, and the ambient environment are crucial for accurate calculations. This is where the expertise of a qualified electrical engineer becomes invaluable. They possess the knowledge to assess the nuanced requirements of each project and make informed decisions regarding lighting design. Furthermore, local building codes often impose additional regulations and requirements concerning lighting power density. These codes may be more stringent than the NEC guidelines and must be adhered to for compliance. Failing to comply with local codes can result in costly rework and delays. Energy efficiency is another critical aspect that should not be overlooked. Modern lighting technologies, such as LED fixtures, offer significant energy savings compared to traditional lighting solutions. Integrating energy-efficient lighting systems can reduce operating costs and contribute to a more sustainable building design. Lighting controls, such as occupancy sensors and daylight harvesting systems, further enhance energy efficiency by automatically adjusting lighting levels based on occupancy and ambient light conditions. Ultimately, a well-designed lighting system should provide adequate illumination for the intended tasks while minimizing energy consumption and ensuring occupant comfort. This requires a holistic approach that considers all relevant factors, from the NEC guidelines to local building codes and energy efficiency considerations. The NEC acts as a baseline, but the ultimate responsibility lies with the electrical engineer to tailor the lighting design to the specific needs of each project. Remember, lighting design is not just about providing light, it's about creating a safe, comfortable, and energy-efficient environment for building occupants. The initial watts per square foot values are merely starting points. A deep dive into the specifics of the project is always warranted.